Okay, Jai Hind all and my dear students. I am Dr. Sarika Kalra, Associate Professor from EN Department, Ajay Kumar Garg Engineering College. So I am teaching right now the electric vehicle. It's a very recent subject and the code is KEE090. So today I am discuss about the topic, the recent trend of electric vehicle. What are the challenges we are going to face? Because all the industries nowadays are moving towards to making the EVs. All IC engine based vehicles are replaced by the electric vehicle, and the governments also have taken so many initiative for this EV to come up with this with the new technology. So before start with this, first we see that is electrical vehicle is it's a new thing for us, or it can be implemented in the last uh, maybe a decade before. So yes, the electric vehicle has been made in the earlier era also, but due to not non popularity of this, the electric vehicle uh, is high because of the IC engine go like moving ahead. So before like now we'll start the what the history behind it, the electric vehicle, because nowadays it is very important for industry to make the EVs and take the challenges, how what are the challenges are coming up with this EVs. So when it started, well, we see that the history of this EV. So it has started from 1830s, like battery, the EVs, the battery based electric vehicle invented by the Thomas Davenport Robert Anderson, that uses the non rechargeable battery. So that's why it is not covered the very large distance, and the technology of charging is not being developed that uh, during that times. So Devonport car holds all vehicles land speed record until 1900, right? Then 1890s, the EV outsold gas car has been come up, and some of the more companies also come up started with this the electric vehicle. Then again in 1904 era, the first speeding uh, car will be developed. The EV, the electric vehicle, is developed, and the Krager company built the first hybrid car. Hybrid in sense it's combination of the IC engine and the electric motor. Then in 1910s, mass produces Ford cars has been developed, the EVs, and the EV passes as status symbols and utility vehicles until Great Depression. So these are these is the vehicle which is based on the electric vehicle, but it is like it is built in 2018 1914. This is this is and these are the first this is the first in 1990s this the electric vehicle has been developed. So timelines, you see the timelines, it's now it's not a new thing, the electric vehicle, but the the demand is now it's new. So in 1974, between 1974 to 1977, one successful electric car at this time is Sebring city car has been made. The company produces more than 2,000 cars that can be the range of the speed will be 50 to 60 miles. Then Then some interested 1979, it will compare to the gas powered car. Electric vehicle at this time have the drawback that include limited performance and the range, causing interest in electric car to avoid. Then in new regulations, again the renew of electrical vehicle interest has been created. In 1990s to 1992, new federal and state regulation create the renewed interest in electric vehicles. The results, like automakers begin modifying popular vehicles models into the electric vehicles, enabling them to achieve speeds and performance much closer to the IC based or gasoline powered vehicles. Then in 1996, the GM, the General Motor, releases the EV1, an electric vehicle that was designed and developed from the ground up, and the EV1 it's quickly gained the cult following. Then in 1997, first mass-produced hybrid, the vehicle has been introduced by the Toyota, and in 2000, Toyota releases the Prius worldwide, and it become an instant success because it has a like a better performance and better speed range. Then in 1990s, building a better electric car, behind the scenes scientists and engineers work to improve the electric vehicles and their batteries. Because in electric vehicle, battery is the major issue, how to destroy this battery. So this is a major issue. In 2006, Silicon Valley startup takes on electric vehicle. Tesla Motors, it produces a luxury electric sports car with the range of 200 miles. Then in 2019 and between 2013, some vehicle, the energy department invests a nationwide charging infrastructure, installed 1800 residential, commercial and public chargers, including charger installed by automakers and other private companies. So in 2010, first commercially available plug-in hybrid has been built for the sale. So GM, that is General Motor, releases the Chevy Volt, making its first commercially available plug-in hybrid. And the Volt uses battery technology developed by the US Energy Department. So this is how the EVs move towards the era to era, and after 2010, Nissan launches some of the EVs. Then in 2013, the electric vehicle battery cost will down, so it will be the great start by 50%. The cost will drop by 50%, so it is helping to make the electric vehicle more affordable for the consumers. Then in 2017, the future of the electric cars, basically. So electric vehicles hold a lot of potential for helping the nation create a more sustainable future. If the nation transitions all the light duty vehicles to hybrid or plug-in electric vehicles, they could reduce their dependence on foreign oils while lowering the carbon pollution and the transportation sector. So now, why the electric vehicle? Because we have seen previously like how the electric vehicle are, the industry or the government is interested in electric vehicle to make the electric vehicle in the very old era. After that, due to the low performance, low speed range, it will be avoided because IC engine based vehicle give you the higher efficiency and basically the more affordable for the consumers. So why electric vehicle? Because it, like, if you see the electric vehicle are called the EV, uses one or more electric motors or the traction motor for propulsion, and electric motor or the electric vehicle will be powered with the battery, solar panels or the electric
generators to get the necessary power to drive motors. So EV includes, but not to limited to, road and rail vehicles, aircrafts and spacecrafts. So, like EV first come into the existence in mid 80th centuries, right? So modern internal combustion engine has been dominated propulsion method for the motor vehicle almost 100 years, but now the electric power has remained common in other vehicle types such as electric trains. So the electric vehicle is a vehicle that operate an electric motor instead of IC engine, the internal combustion engine that generate power by the burning a mix of fuels and gases. So if you replace the IC engine by the EV, so this will help to environment to clean the environment, because if you see the Indian scenario nowadays, there is a like if you see the overall Indian scenario, like if you compare this with this AQI, that is air quality index. So if you see this is, if the air quality index is between 0 to 50, it will show that it's the air quality is like its effect in the health, minimum effect in the health, right? Then if it is 15 to 100, it will be satisfactory. Minor breathing discomfort can be seen. If your air quality is 101 to 2000, 200, so the breathing discomfort to the most people uh, has been there. And then it's severe when the air quality index is 400 to 500. That will adversely affect the uh, health of the people. So, and if you see the in Indian scenario, like these red spots will indicate that here the pollution is the very much high, that the air will get polluted in such a way that the air quality is even higher than 400. So in between, so it will adversely affect the overall health issues. So in this you can see that, so because these gases, that air, because this air has the number of gases like carbon, because when the the IC engine based consumption process will be performed, so a number of gases is released and they pollute the environment, and also they are very harmful to the people, the people also. So because the major, if you see the global aspects of the how the air is polluted with this transportation, so transportation contribution is very much high, that is 14%. If we compare with the industry, because industry is also the one source of releasing the carbon emission gases, and transport is also one of the main reasons, and it is its contribution globally, its contribution is 14%. It's very much high. So we have to now, it's alarming time to, we have to stop this this carbon emission to reduce the AQI, the air quality, to improve the air quality index, or to reduce the global warming, right? So that's why the government initiative, the government idea, the industry idea is to replace all IC engine by EV, because transportation globally, if you see the contribution of the transport contribution is 42%. If you compare this contribution in all over, so it's big high, right? Because it is directly emission. The transportation is a sector which directly pollute the air. It's directly emitted the carbon dioxide or the carbon emission gases. So because now the it's alarming time to stop this all, because if you see the number of deaths will be there in the last, like if you see the this is the survey for death due to the pollution. If you see that, so uh, it's globally, it's a number of deaths in million due to pollution only, and due to the transportation pollution only. So if you see the India is the number one, in which the India is in the highest. If you compare with Brazil, USA, Indonesia, Pakistan, the India is the highest, where the death is due to only the pollution, right? So, and if you summarize this factors, why we go for the electric, and why we replace this IC based vehicles with the EV. So if you see this, there's a one big is because of the IC based vehicles is emitting the carbon emission gases that pollute the air quality, and so air quality index can become higher, and that the environment will become pollute, and the global warming has been done. So that will affect the human health also. So this is a major topic, a major concern. The electric car don't, and due to this electric car, it's zero emission. So only this electric car is run by the your motor only, right? Purely electric car. So it can be a zero emission can be possible when we using the EVs. Then offer affordability. So electric car are less expensive to fuel and maintain. Like if you see the maintenance or the running cost, yes, for running, if you see the running cost and the affordable in terms of affordability and in terms of maintenance, you can save a lot of money, because one time investment cost is higher than the IC base, but there is no fuel consumption will be not there. So every month, uh, there's no need to fill up the tank. So it's actually the free of cost to maintain, and the maintenance is easy. So it can be running cost is very cheap. So it can be, anyone can be afford. Yes, first time investment is higher, but uh, the to maintain it for a longer time, it is bit in terms of cost, it will and in terms of maintenance, it can be uh, easy to maintain. Then the reliability and flexibility. Electric car require less maintenance, as I said. New model hitting the market also offer more flexibility of car size and style. Right, the infrastructure is not very much complicated. The gearbox is not there inside, and the clutches is not there. So it's automatic. You just push the accelerator, and it will speed up the car. So no mechanical part will be there. So the size can be utilized for battery, and it's it's easy to maintain. Ground infrastructure, you can plug your car and ride. Yeah, for this to charge the battery, you can easily plug the car in your parking stations and parking area, or the home at home also, and more area have charging station for when you are go. So next, if you see like greenhouses gases emission, the India is one of the top countries. So you have to take care of the, like India. If you see the emission gases in India, it's 6.4% contribution in the environment. So it's huge percentage. So China is So one of the highest, 25.9, US is 13.9, then food waste is 6.7, the Russia is 4.9, the India is 6.4. So, so the greenhouse gases emission by the India contribution 6.4%. If you see in terms of efficiency, like this is the battery uh, electric vehicle, this is the fuel electric vehicle, this is ICV based engine electric vehicle, fuel cell electric vehicle. So if you see in terms of efficiency, so electricity when because at the EV the input is the supply, the DC supply, right? So it's 100% efficiency is at the input side. So it goes to the battery, then to the motor driver, then to a wheel. If you see the power flow, like in this way, the power flow will be there. So in the battery, some losses in the battery, then the motor drive, it's some stator losses, the rotor losses, and the sub transmission losses will be there. And at the wheel, 72% efficiency you are getting with the help of this uh, battery electric vehicle. If you see the fuel cell electric vehicle, 100% efficiency and goes through away the flow of power, direction of flow of power, and the flow of percentage power will be like this. So it's till fuel cell it goes 55%, then motor drive, then up to wheel you are getting the 40% efficiency. Now the power remaining is 40%, right? In IC engine base it's a 16%. So if we compare the efficiency with the battery based electric vehicle, so the efficiency is much higher than this fuel based electric vehicle and this IC engine based electric. Now to build up this what are the challenges you have to face for this? So these are the challenges in 4 sectors, like in technical, all the challenges I can distribute in the 4 sectors, like market sector, policies, infrastructure, and the technical. So if we see them in terms of market value, so these are the challenges is come up, and the industry have to face these challenges uh, to to grow in the field of electric vehicle. So first challenges is like the vehicle has to be the how much electricity quality should be given to the EV. So grid voltage, what is the grid voltage and how voltage profile is given to the EV. That is a big challenge. And what criteria of storage of electricity has been taken up, right? And what kind of battery raw material can be used for the battery, right? Because battery is dependent because in battery, like how much time it take to charge, how much time it take to discharge, and in one charge how much kilometer it covers. So that matters. So that challenge has to be faced by the industry to make the better AV. So these are the challenges. And the second, in terms of technical, uh, how much efficiency are like uh, we are getting with the EV if you compare with the IC, and what kind of motor driver uh, technology has been used so that you'll get the higher efficiency, better efficiency. What kind of like how much torque you are uh, high torque density is required, high power density is required, what kind of speed range you are getting with this help with the use of this motor drive technology. So these are the challenges, and what safety arrangement has been done, because if the temperature is also very important factor for the battery purpose. So if the temperatures go up beyond certain limit, so that has to be, the cooling arrangement has to be there. So and what the charging time, as I said, right? Then in terms of infrastructure, like because charging station, if you have the electric vehicle, the charging uh, is a very important part, right? What charging station have like charging station should be there to charge the battery. So all ice like oil based all based infrastructure has been replaced by the petrol pump is replaced by this charging stations, and at home or at garage or at residential area there should be a charging station, charging port should be there. So battery recycling is also important. Battery dispose of and how to recycle the battery. By battery dispose of is also very important and very challenging factor. How to dispose of the battery, because uh, what is the if the life of the battery is 10 years. After 10 years, you have to dispose of. You have to recycle the battery. So what are the for recycling? What are the arrangement has been done, right? What are the charging infrastructure, because every if the your in one charge your vehicle is for running for 200 kilometers, so after that you have to again charge the battery, so there must be a charging station. After certain distance, after certain kilometer, the charging station should be there. So that has to be uh, challenges when you are making the making the evs. And in terms of policy, so the consumers are still dependent on the IC engine, because they're comfortable in terms of you just use the petrol, just fill out the petrol and just go anywhere. There's no terror for this key, like if it is just discharge, how will charge the battery, how will charge the your vehicle. So the to develop the interest in the consumer level. So the government has initiated some policies, like some subsidize the rate, to some incentives are must be there for to motivate to encourage using these EVs, right? So these challenges has to be taken up, and with this we can move forward for this EV. And if you see the barrier, as I discussed earlier slide also, technical barriers involve issues related to the efficiency of the batteries, charging time, and driving range. As I said, driving range is the speed range, because initially it requires a small speed and the higher torque. Then again it requires a higher like higher speed and the lower torque. So that has to be achieved with this EVs. One of the major barriers to low specific energy density for the most batteries used in the EVs, especially lead acid batteries, they have the low energy density. So we have to, so some challenges has to be taken to increase how to increase the energy density of the battery. So to achieve reasonable driving range, require bulky batteries, adding to the overall weight. If you increase the driving range, you have to increase the if you increase the driving range or increase the rating of the motor, so you have to increase the size of the battery. That can be that increases overall size of the EV. That is also a major challenge, or you can say barrier for this. So battery manufacturers are working on advanced batteries with the higher specific energy density, such as lithium ion. Lithium ion, because now research has been done, and lithium ion batteries are the higher energy density. So that can be used at a lower size. So overall size can be reduced with the help of this lithium ion, and the rating of the speed range on the rating can be increased. So electric vehicles, now these are the some challenges. Again, the same things I have discussed again, because it's very important for this. These are the key points that can be considered. So reduced range, electric engine are the kind of limited mileage range. The less power the electric engine will follow the gas engine. The top speed maximum out of 70 and expensive. and the small amount of pollution. Classified as a green cars. So using this like EV, the pollution, it can reduce the pollution. Zero emission can be takes place. Initially it cost is high, because initial cost is high, but if you see the running cost, it can be reduced because there's a no and easy to maintain, no again and again refilling of petrol is required, right? And also the rating of the like high power density can be increased. So if you increase the power density, size of the motor, size of the battery can be reduced. So these are the benefits of this electric vehicle, right? And also we can increase the range of the speed. So this is all about what challenges we have to take of electric vehicle, what is the history behind this, where the electric vehicle comes. It started from 1980s and come up in 2000, 1997. Then the research has been going on, right? So in next lecture, we'll see the architecture of the EV, and uh, then we'll see the what kind of motor we are using. So today's lecture will stop here. Thank you.